Alright, welcome you guys, and we're talking about the second lesson of this unit, which is conditional statements. Okay, so conditional statements are just ways of writing statements that make sense or don't make sense. Okay, and sometimes you have to write it a little bit backwards to understand it. So the first one we'll talk about is a conditional statement. Now, a conditional statement is actually made up of two parts. So it will always say if hypothesis, and then my logical conclusion. Okay, so my definition of a conditional statement is actually made up of two other definitions in the list today. Okay, conclusion and hypothesis. Alright, so basically this is just a statement about any general idea, and then I come up with a conclusion based upon that. Okay, now in math we have this as P, then Q. Okay, so that would be an actual conditional statement that works with it. Now, does the hypothesis always come first and then the conclusion? Yes. Okay, unless you switch it and then it becomes a little bit reverse of itself, and we'll talk about that because that is called a converse. Okay, so right now this is a conditional statement. Okay, and conditional statements are literally what they are. They're conditional, they're based upon certain rules. You know, this one right here is called a converse. And a converse is just a reverse of the conditional. So in other words, instead of saying in the conditional, if I went to the movies, then I'll eat some popcorn, in the converse you would say, if I ate some popcorn, then I went to the movies. Okay? Alright, now another interesting little mess around with this is called the inverse, which is just the negation of the original statement. Okay, and I'll explain what negation means in a second. Okay, and you use this little tilde to represent it. Okay, and this is called an inverse. Okay, so in other words, if the original statement was, if I went to the movies, then I'll eat some popcorn, the inverse is saying, if I didn't go to the movies, then I won't have eaten popcorn. Okay, and probably some of you guys are already thinking of some counter examples to that statement, and that's good because you want to do that. Okay, alright. Now, you probably also wondered why the tilde key was represented so much. In math logic, it's called Boolean algebra. It's actually computer science algebra. You need to use this tilde key to tell the computer when to say not. Okay? Contrapositive. I always forget what this is called. Okay. In other words, it will tell the computer whatever statement comes next, think of the opposite, and that's what I'm trying to tell you. So tilde is such a unique key to have all to itself, but in fact it's actually essential for computer programming. And it's kind of it might be a leftover from the olden days, but if you use tilde today, there's a lot of good things you can do with it. Okay, so conditional. If I go to the movies, then I'll eat popcorn. The converse would be, if I eat popcorn, then I'll have gone to the movies. The inverse would be, if I don't go to the movies, then I will not have eaten popcorn. And the contrapositive, which is the last one, which is just the negation of the converse. The contrapositive says, if I don't eat popcorn, then I will not have gone to the movies. That's what the contrapositive is saying. Okay, so there's some really cool stuff that we just talked about. Okay, and that's all this stuff. Now we do have one last part to talk about, which is equivalent statements. Okay, now interestingly enough, these two will always tell the same story. It's weird, but it works. And same thing with these two. It's just how it works. I don't know why. It just makes sense how it works, and it just works out. Okay. All right. Now a truth value, and this one's a tough one. Trust me, you're not gonna be the first ones to be lost if we have to go over truth values. Okay. Truth value will actually take several of these. Let me go black. There we go. Okay, and you can actually say some statements about it. And you actually have to use some logic with it, okay? So what you have to do is you have to have a header up here, and then you have several spaces for true or false statements. And it doesn't matter, it's just the truth value that matters. And this is hugely important in computer science. It's hugely important in just any kind of argument you want to take. Okay, so let's say that this is P, this is Q, and let's say this is P, then Q. If P, then Q. Now, if hypothesis, then conclusion, we've talked about the different types of conditional statements. We haven't talked about exactly what it means to say it. Okay, there's this rule, and you'll be learning it in the, I think it's unit, or no, not unit. In lesson 4, it's going to be called a law of detachment. But basically, here's a really cool thing. If this is true, then this has to be true. Whatever I say has to be true. And we're going to use capital T's for this, and we'll explain it more in a sec. Okay, so I'm going to use capitals, so let's go T, T, and we're going to do a mixture of them, T and F, F, then T, F, then F. Okay, so in other words, I'm going to tell you a true statement. I'm going to tell you the truth value of the conditional statement based upon these ideas right here. Okay, so if P, so if I go to the movies, which is true, then I will eat popcorn, which also happened to be true, then I told you the truth. Okay? All right, now if I go to the movies, which is true, but I didn't eat popcorn, but I told you I ate popcorn, then I told you a lie, which would make it false. Okay? Now, here's an interesting part, and this is called the law of detachment. Okay? If I didn't go to the movies, but I told you I went to the movies and I ate popcorn, that doesn't stop me from telling you the truth that I ate popcorn. That's a weird statement. Okay? All right? And this one down here, if I don't go to the movie, if I said I went to the movies and I didn't eat popcorn, I still told you the truth, even though I lied to your face, according to this truth table. It's a really interesting function in how it works, and this is actually how truth tables line up. Now, the reason why I have to follow that is that if this is true, then the following has to be true. But if it's false, whatever I could say back here could also be true. Let me give you a different example than the popcorn in the movies. If I give you $1 million, then I am the President of the United States. Well, if I don't ever give you the $1 million, I could be the President of the United States, I could not be. It doesn't matter. I'm actually saying a truthful statement. It's weird how it works that way, but it actually works that way. Okay, and that's what you're going to have the toughest time with is truth value tables. Okay, so don't feel bad that writing this stuff out is going to be kind of hard. Now, here's the cool thing, though, is, and like what I just talked about, the conditional and the contrapositive are true. So if I wrote down here, not Q, then, oops, I need to get rid of the capital letters. Not Q, then not P. Okay, that's the contrapositive. I know without a fact because these are true. These are truth equivalence statements that these are going to follow the same logic. And it's really weird how it works that way, but it just does. Okay? And if you think about it, if you read it with the not statements in here, the negation statements, okay? All right, you have to almost read it instead of going from left to right here. You have to read it from right to left, and then you have to think about the opposite of what's going on. So if not Q, then not P. Okay, so not Q is not true, so that would make this, well, that's true that I get a not Q. Okay, then not P shows up, so that would be true. Okay, if not Q and that's false, which is not a good thing, then I get a true statement for P, then that's going to be false. And it works on from there, and it gets all kinds of crazy. Okay, but this is conditional statements. Just please understand that We're just testing you out on it and stuff and just working with it. Now, in the conditional statements, I want you to pay attention to this fact that the hypothesis does not have an if in it and the conclusion does not have a then in it. So if you're stating the hypothesis and the conclusion, do not use if and then. Okay? Alright, you guys, that's pretty much it. This is a pretty fun section to work with. It's something different than what you've worked in math before. So I hope you have a good time. Alright, talk to you later.